Hey guys, welcome back to Tekneikos. Today we are going to understand namespaces in Kubernetes. This is very important to understand this concept. And before we go to namespaces, I want you to know that we have already created two more videos. One is introduction and architecture of Kubernetes, and the other one is pods in Kubernetes. This is highly recommended. If you have not seen the video, please go ahead and watch the first and second part of the Kubernetes series. And if you need any kind of personal help in terms of your career guidance or anything, you can directly reach out to me through my LinkedIn. It is available in my bio, and please subscribe to Tekneikos for more content. So let's start namespace. So a namespace is a logical partition inside a Kubernetes cluster. So for example, you have a cluster here. Okay. So inside that we have something logical partitioning. Okay, so it divides the cluster into two pieces. So you can run two different pods in two different places. You will feel that you are having two different clusters, but it is not a real cluster. It is just a partition, which is a virtual partition. It helps you divide one cluster into multiple virtual sections. Okay, so you can have multiple virtual sections like this. Now you have four different sections. So why this is needed? At the first place, you need to understand we have a team. For example, we have let me just write it here. Suppose we have a team of dev, testing, stage, production. Okay, these are four different stages of software development lifecycle. Okay, now each team has to work independently. The code which is in the dev should not directly go to your production. Okay, that is a big blunder. The dev code should go to testing, and testing people should do testing. It should go to staging, then it should go to the production. The code which goes to the production should be the final one. Final one should be clear of all bugs, free of all bugs, have some security checks, and a lot of things should be done. Okay, before it goes from dev to production, it has to go through a lot of steps. Okay, for that reason, we have multiple virtual partitions inside the cluster. So for example, your organization cannot have different clusters for different environment. For example, we have one cluster for dev, one for PRD. That means it is fine. You have two different clusters. You can use it as you want. You can do all your development in the dev cluster. You can do your production stuff in the production cluster. But for some reason, for some cost reason, of course, organizations may not have two different clusters. So what they do, they use the concept of namespaces. So they partition their environment, single cluster, into multiple namespaces. They have their namespace for testing. They have their namespace for production. They have their namespace for dev and stage. So all these stages will be separated, isolated, and does not affect any of the other environment. Okay, the problem without the namespace, we need to understand this. In a single cluster, multiple teams may work together as a front-end team, as a back-end team, as a DevOps team, as a QA team. Okay, this is a very normal thing. So without the namespace, what is going to happen? So everyone creates a pod in the same place. So for example, we have one cluster. So the dev team creates a pod, then the testing teams create a pod, then the QA team creates a pod, everyone having a pod. So we cannot segregate them, okay, based on the environment. A pod may scale, a pod may scale down, and it is possible, and this is a very famous problem in the Kubernetes world, noisy neighbor problem. Okay, so what is this noisy neighbor problem and how it occurs? So this happens when one pod or workload consumes too much shared resources like CPU, memory, disk space, or network bandwidth, which negatively affect other pods running on the same node. Okay, so for example, this pod is a dev pod. Okay, now a user changed something, and this one is creating a lot of problem for others by using a lot of memory. Suppose this one is a node. Okay, let it as a node. Now this expanding. It is causing problem for others. So this is called noisy neighbor problem. Okay, to make or to stop this, we use namespaces. Now we segregate them with a virtual boundary. Okay, now this cannot just grow like this and start using any other pod's resources. It has to be stopped under its own limit. Okay, I hope the noisy neighbor problem is clear to you. Again, a few more problems. Hard to manage resources. Of course, if you don't have a namespace, you don't know which namespace is using how many resources, and it is hard to control access. Okay, so we can give access to certain namespaces, what they can actually control, and hard to separate environments. So as I shown you, this is a cluster, and this says mixed pods in a single cluster, which means this is front-end pod, this is back-end pod, this is Nginx pod, this is MongoDB pod, this is testing pod, this is QA pod, without any namespace. Now if we add a namespace in between them, this will be like this. So these cannot create any issues for others. Okay, we have seen what is a namespace. It's done. A namespace is just a logical partitioning inside the Kubernetes cluster, helping divide one cluster into multiple virtual sections. Each namespace can contain pod, services, deployments, config maps, secrets, all the Kubernetes object it can have. Okay, similar to what I have been showing you. So this is the Kubernetes cluster. We have dev namespace, we have testing namespace, we have stage namespace, we have prod namespace, and each one of them is separated by a virtual layer and having their own pods running, okay, and not harming each other. Now again, why namespaces are important? This is important. If interviewer asks you, so you should be able to answer that to organize resources, to separate environments, to avoid naming conflicts, to limit their access, to apply resource limits. I told you about noisy neighbor problem. You can explain the noisy neighbor problem here, and to manage multiple teams. So again, the problems without this image shows the problems without namespace in a simple format. So we cannot have same name, and we will end up having a pod name conflicts. We can have same name in different namespaces with the use of namespaces, and resource mixing is again, if we don't use any namespace, it is too many resources together, it will be a problem. Access control, okay, developers accessing the production and all these things we can resolve with the use of namespace. So I told you, you can have same pod name in different namespaces. Okay, that is allowed. So Kubernetes allows the same resource name in different namespaces. These are allowed because they belong to different namespaces. For example, you can see we have a dev namespace, we have a staging namespace, we have production namespace, and each one of them having same pod name and same backend pod name and same MongoDB pod name, but they are in a different namespaces, so that is allowed. So sometimes interviewer might ask you whether this is allowed or not, and you get confused. So with this picture, I guess it is very clear to you. Now again, this is very important. There is a default namespace in Kubernetes. So initially, when you don't define any namespace, you will end up creating your resources in a default namespace. Okay, default namespace. Default namespace is the built-in namespace which has default kube system, kube public, and kube node lease. These things you can find in the default namespace, and you should also know the purpose of this default namespace. So with this namespace name and the purpose, I have written in a table. So default users resource go here, which means if you create any resource like a pod without specifying the namespace name, you will end up creating that pod in the default namespace. Then comes the kube system. This holds the Kubernetes internal components. Okay. Then comes the kube public. So it holds the publicly readable resources. Then comes the kube node lease. This is for the node heartbeat information. Okay. So you're in a bigger picture, you have a cluster, you have a node, and inside that node your pods are running. So your node is running or not, somewhere has to be stored. That is what this kube node lease is useful. Okay. Now some important components inside the kube system, we need to discuss this as well. So the kube system namespace typically contains core DNS pod, okay, metrics server, scheduler, controller manager. That is why I told you to check out my first video, Kubernetes Introduction and Architecture, where we have discussed about all these important components in Kubernetes, the kube proxy, etcd, scheduler, controller manager, everything we have already discussed. Okay, we should never delete the kube system namespace. So let's discuss some of the important commands. To get the namespaces, we need to run kubectl get namespace, or we can directly write a short form ns instead of namespace. Okay, to create a namespace, we need to run a command called kubectl create namespace dev. Dev is the name of that namespace, testing is the name of the namespace, production is the name of that namespace. Okay, we can create using the YAML, and the YAML looks like this: API version, then comes the kind, then comes the metadata. The kind should be namespace, then comes the dev. Okay, name. To create a pod inside the namespace, we need to run these commands like kubectl run nginx pod dash dash image equals to nginx port 80. If we run till here, it will be created in the default namespace. But if we do like this, if we mention -n and dev, it will create in the dev namespace. And we can view that pod being up and running with the command kubectl get pods -n namespace and dev namespace. Okay, so let's understand a pod creating with namespace with using YAML. So we will define a API version, we will define pod, we will define metadata. Okay, here we will mention inside the metadata namespace equals to dev, and rest remains the same for pod creation. It will make sure that it is created in the dev namespace. Let's understand few resource allocations. So namespaces isolate resources logically. We know that we have a pod example. Pod in dev namespace cannot automatically see pod in the prod namespace by simple name. We need to mention the namespace name along with the pod name. That only the possible scenario where it can access. Services are namespace scoped, config map are namespace scoped, and secrets are also namespace scoped. What does that mean? So this means that the services and config map exist only inside its own namespace and cannot be directly accessed from another namespace unless you explicitly specify that namespace. I told you that pods can communicate across namespaces if needed. For example, backend.service.dev.sbc.cluster.local. So let's understand that concept in this diagram. So pod in the prod namespace and service in the dev namespace. Okay, this is an API endpoint in the development. This is application instance in the production. So how we can communicate service name dot namespace name dot svc.cluster.local. Okay, so we can able to make a connection between them. Now let's understand resource quotas per namespace. So we can define a quota limit, resource limit to namespaces. For example, Kubernetes can limit CPU, memory, number of pods it can have, etc. per namespaces. And default CPU and memory limits can be set for containers in the namespaces. So namespace dev automatically applying default CPU request, default memory request, default CPU limit, and memory limit. Memory limit is for ensuring the memory uses. CPU limit is of course minimum CPU resource allocated to workloads. Then comes the memory request, sufficient memory resources guaranteed for processes. Let's understand RBAC and namespaces, how they have a relation. So RBAC full form is rollback access control. Rollback access control gives you access only to specific namespaces. For example, a developer can access the dev namespace only. A developer working in the dev namespace, so this is a cluster, this is a node, and we have a partition. There is a dev namespace, there is a prod namespace. This one is dev, this one is PRD. So rollback access control makes sure that a guy who has access to only dev can access dev namespace, can never access prod namespace and prod pods. So QA can access testing namespaces only, admins can access full namespaces or all namespaces. So this is one simple command to change the default namespace. kubectl get set context current namespace equals to dev. After this kubectl command use the dev namespace automatically, so you don't have to mention ns and then namespace name. So default would be dev. So I have mentioned before. After that you can see when you search kubectl get pods, it would result you in the dev namespace. When you now use, if you search after, it will show you the dev namespace resources and pods. Now let's understand how to delete a namespace. You can delete with the simple delete command, kubectl delete namespace and the namespace name. Deleting a namespace deletes everything inside it. This is very important, you should understand. So if you delete a namespace, it would delete pods, services, deployment, config map, secret, everything. So as I promised, I will be guiding you with some important interview questions as well. So what is a namespace in Kubernetes? You can answer, a namespace is a logical partition inside a Kubernetes cluster. It helps organize resources like pods, services and deployments, config maps and secrets into separate sections. Why do we need namespace? I told you, to separate environment, to avoid naming conflicts, to organize resources, to control access using rollback access control. Please mention about the rollback access control, this is important, and also apply CPU memory limits. So what is the difference between a cluster and a namespace? Although this is a fairly simple question, but they might ask you to confuse you in between the interview. So a cluster is the complete Kubernetes environment containing all nodes and resources. A namespace is the smaller logical section inside the cluster. Okay, a cluster is having dev namespace, testing namespace, pod namespace. Now I told you they might ask what is default namespace in Kubernetes. You can start like Kubernetes comes with a default namespace, having default used if no namespace is specified. Kube system stores Kubernetes internal components. Kube public stores the publicly readable resources. Kube node release stores node heartbeat information. Again, they might ask you to explain this kube system namespace. You can explain kube system namespace is a special namespace used by Kubernetes for internal components. It usually contains core DNS, kube proxy, scheduler, controller manager, metrics server. Now this is very important, cluster scoped versus namespace scoped resources. Because a lot of tutorials I have seen, they miss to actually demonstrate or show the difference between the cluster scoped and namespace scoped resources. And the beginner, they think that the namespace itself is everything. No, there is a concept called cluster scoped. We need to understand what it is and what it does. So not every Kubernetes resources belongs to a namespace. Okay, the resources which belongs to namespace are pods, services, deployments, config map, secrets. Then comes the cluster scoped resources. For example, the node, the persistent volume, the namespace itself comes under the cluster scoped resources. Then storage classes. I have created a diagram. So what it does, so namespace scoped resources are pods, services, deployment, and cluster scoped are nodes. The nodes are itself the machine where the pods are running are managed by cluster scoped resources, namespaces, storage classes, persistent volumes. So we should understand what is the difference between them. If you ever been asked in an interview about this question, just mention that namespace scoped resources exist only inside a specific namespace like pod, services, config maps, but a cluster scoped resources exist across the entire cluster and are not tied to any namespaces like nodes, persistent volumes, namespaces, and cluster roles. So let's summarize the whole thing. Namespaces helps to organize the cluster resources, separate environment, avoid naming conflicts, control access, apply limits, and you can, in a simple words, you can understand namespaces as a folder inside the Kubernetes cluster. Then comes the Kubernetes namespace hierarchy, resource limiting at the top, access control, we have a naming conflict avoidance, we can have a separate environment, we can have a resource organization. Same thing what is written here I have explained in the terms of visualization. So if you are wondering how I created this, I used Napkin AI. This is not a promotion, just if you get confused how I can able to create all this. So I prompted that I want this kind of visualization, and it created. So thank you for watching. I hope this tutorial helps you. We are going to upload more tutorials on Kubernetes, so please subscribe to the channel, and Kubernetes like never before playlist, you can go here and watch all our videos. And please, if you have any doubt, you can directly connect to me through the LinkedIn.